Hello everyone. In this video, we will continue to discuss topic 9.3 interference, and in particular, we will discuss thin film interference, as well as describing the conditions necessary for constructive and destructive interference from thin films, including phase change at the interface and the effect of refractive index. In the previous video, we derived equations governing thin film interference for constructive and destructive interference. But it is very, very important in this particular subtopic to recognize that these equations, the ones given, are for situations that involved a single phase change. This will often be a bubble, but it's really any case where you can think of the indices of refraction as forming a sort of sandwich, where n1 and n3 are both less than n2. There are situations for thin film interference, though, where you need to account for the fact that those reflected rays will undergo two phase changes. Will they undergo a phase change at both boundaries? This might be sort of seen in an example like the worked example right below. This worked example describes a case of a solar cell which is being coated with a thin film to try to minimize the reflection of light. As a result, the coating is of index of refraction 1.5, and the solar cell itself is at a very high index of refraction of about 3.5. As a result, you get a phase shift at that first boundary just as before, but you also get a phase shift at the second boundary. And as a result, the conditions for constructive and destructive interference don't involve the extra phase shifts from both, because both outgoing rays are phase shifted. And the equations for constructive and destructive interference look exactly like the equations for one phase change, except flipped. And in fact, they actually look normal. So the constructive interference occurs for a situation with 0 or 2 phase changes where 2dn is an integer number of the original wavelength. And destructive interference occurs where the case at the case where 2dn is equal to a half integer number of wavelengths.